Okay, so topic 9 of Unit 4 is about linear function transformations. So problem number 1 says the graph at the right shows the linear parent function y equals x. Okay, then they're wanting us to graph these 4 remaining equations on the same graph. So first is y equals 2x. Remember that graphs typically, or equations are typically written as y equals mx plus b, and that allows us to see the slope, in this case 2, and the y-intercept. Well, just because you don't see one written right here, it doesn't mean that something's wrong. It just means that the y-intercept is a 0. So it goes to the origin, okay? So I'm going to go over to my graph here, starting at the origin. My slope is 2, so I need to go up 2 and over 1. Up 2, over 1. Continue that all the way up the graph. You can also go back down the other way by going down 2 and to the left 1. Connect those. Okay, first line done. There's y equals 2x. Okay, notice how it compares to the parent function. Same y-intercept, but obviously it is different. Okay, let's do y equals 5x, right here. Also starting at the origin, but my slope this time is 5, so I go up 5, 1, 2, 3, 4, 5, over 1. Same thing, I go down 5 to the left, down 5 to the left. So when I connect those, okay, again, the same y-intercept, but it still looks a little bit different, right? Let's keep going. We've got y equals 1/2 x. Do green this time. Same y-intercept at the origin, but this time it goes up 1 over 2. Up 1 over 2. Connect. Okay, last one, y equals 1/4 x. Make this one yellow. Same origin y-intercept. Up 1, oh, that's wrong, over 4, and we connect. So we're going to pretend we're doing like Blue's Clues or Dora Explorer or something, and I'm going to ask you a question. Think about it, and then we'll write the answer down. So what do you notice about the graphs? Good. Was that fun? Hopefully, you notice that they all have the same y-intercept, okay, of 0, 0. They have different slopes, as we could tell from the equations, but what that means is that they have different steepnesses, which may or may not actually be a word. Steepnesses. Okay. The 2 on the top, 2x and 5x, those were steeper than the parent function, right? And in fact, 5x was the steepest. Okay, 1/2 and 1/4, those were less steep. Oops. And 1/4 was really the least steep, okay? So what you're supposed to notice here is that as you change the slope, you're making the graph steeper or flatter, okay? Hopefully you learned that a little bit just from doing the marble slides activity. So let's try this again. It says the graph at the left, which really this should say the right, shows the linear function y equals 4x minus 1. So this is not the parent function. This is y equals 4x minus 1. So it says graph the following. Y equals 4x plus 2. Okay, so let me go graph that. We're starting at 2 this time. Slope is still 4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. I could also go down 4 into the left one. And then let me connect those with the line. Okay, so there's y equals 4x minus 2. It's kind of confusing to have this label here. Purple one's y equals 4x minus, or plus 2, sorry. Okay. See what you notice there. Let's do the next one. Y equals 4x minus 6. So the y-intercept here is negative 6. I'm going to do, again, a slope of 4. Okay. Then something changes here. We have y equals negative 4x minus 1. Okay, so still minus 1, but this time it's a negative 4x. That means when I count my slope and I go up 1, 2, 3, 4, I go to the left one. 1, 2, 3, 4 to the left 1. Okay, same with going the other direction. I'm going to end up going down and to the right. Okay, so then again, what do you notice about the graphs? Well, in this case, we had the same slope every time, okay, but different y-intercepts. So, in other words, these graphs have been shifted up or down, okay? Then we also have this green line, right? It was not shifted because it was at the -1, and it's not changed as far as the steepness is concerned, right? The only thing that's changed is that now it has a negative slope, okay? So let's summarize down here. It says changing the slope affects steepness. The higher, the steeper. The higher the number. Lower, flatter. Okay, now changing the sign of the slope reflects the graph. Okay, in other words, it'll go from a positive slope to a negative slope or vice versa. It really is reflecting the graph over the y-axis. Or really, again, just changing the direction. But it doesn't change the steepness necessarily unless you actually change the number. Changing the y-intercept affects the position. Okay? This is when you would translate the graph. So thinking back to last year, we talked about reflections as a transformation and translations as a transformation. Same thing with equations. You can still reflect and rotate and translate all the things you can do with like a triangle, you can do to a function itself, okay?